Okay, so today we're going to learn how to graph cosecant and secant, which is actually not all that different from graphing cosine and sine, which should make sense because cosecant and secant are closely related to sine and cosine. Specifically, we're going to start out with just a little bit of review of what our cosecant function is, which we know is 1 over sine, and secant we know is 1 over cosine. And the reason I'm starting out that way is to talk about those domains of our cosecant and our secant. We already did this last chapter. We looked at the domain of cosecant and secant and looked really just at the denominator that of really 1 over sine, and we knew that this had an essential domain problem because we were dividing by something, and when we divide by something, that something can't be 0. Now that we're more familiar with our graphs of sine and cosine, we especially know these zeros that are quadrantal angles. So we know that sine is actually equal to 0 at 0, pi, 2 pi, 3 pi, and so on and so forth. So these are the values that we have to exclude from our domain of cosecant. So if you remember from last chapter, we wrote it as negative infinity to infinity except those values of k pi, where k is an integer. These are now the zeros of our sine function, and this actually is a really important idea of where our sine function is 0. It comes up when we actually graph our cosecant. Same thing with our secant. These values that our cosine in this case is 0, which happens at pi over 2, 3 pi over 2, if I have a coterminal angle, 5 pi over 2, 7 pi over 2, etc. So we wrote our domain of secant as negative infinity to infinity except those values, and remember we wrote that as k pi over 2, where k is an odd integer. Again, this idea of where cosine and sine is actually 0, it is really important because something special happens to graphs when we divide by 0. Obviously, they don't exist at those values, but what ends up happening is we produce an asymptote at those values. So to explore that a little bit more, I want to graph sine of x, which we've done this a bunch, so something that's familiar. And I've adjusted my calculator so that these actually are values of pi over 2, pi, 3 pi over 2, and 2 pi. And then I'm going to graph cosecant, which is 1 over sine of x, and see what that looks like. So if you can see, we have these like U-shaped graph pieces. They don't actually touch, so if I zoom out, I'll zoom out in a second. But they do kind of hover at the maximums and our minimums of our sine function. So these values, if I go to the table, these values happen, or they share the same y value at, this is going to be pi over 2. So at pi over 2, my y value for sine is 1, and my y value for cosecant is 1. And that makes sense, because if I plug in pi over 2 to this function, I'll get 1 over 1, which is just going to be 1. So if I zoom out off my graph here, again, the first thing that we're seeing is our sine function and our cosecant function will produce all of these like different pieces of our graph. And what happens at these values of where we have like this weird line as it approaches, those are actually our asymptotes, and those happen at the zeros of my sine function. So graphing cosecant and secant is really, really similar. Really what we have to do is we have to graph our regular sine and cosine function, and then we have to find these zeros, and those will be our asymptotes. So these are, so an asymptote is this guideline that represents it where this graph can't touch, and that's because it's undefined or it divides. In our case, we have a divide by 0 error. at that value. Okay, so that means that for our range, if I'm going to zoom in here again, if I look at where our graph of just cosecant lies, our values, and we've already looked at our range before in chapter 1, but it kind of makes sense graphically. We're shooting up to infinity on like the top of these U's, these U shapes, and we're shooting down to infinity at the bottom part, and we reach this maximum over here at 1, which is like the minimum of this U curve here, and the value that we're reaching on this one is -1. So we have two different pieces that we're kind of grouping together. We go from -infinity to -1, and then we start again at 1 and then shoot off to infinity. All this section of where sine actually is not getting touched by our range of cosecant. And same thing for secant, ends up being the same range. We go down to -1, and we'll see a really similar feature too, or we would see a really similar feature if we graphed our secant function. Okay, so we're going to always start out by graphing sine x, which is normally, our normal sine x has the period of 2 pi. We have our critical values at pi over 2, pi, 3 pi over 2. We have an amplitude of 1. So sine starts at 0, up to 1, back to 0, down to -1, and back up to 2 pi. So it looks something like that. So again, at these values of 0, pi, 2 pi, etc., these are really important because these actually produce where our asymptotes are. Cosecant actually can't hit any of those values because we can't actually have something for cosecant at pi or 2 pi because we'd be divided by 0. So these give our boundaries to where our U-shaped graph is going to fall. So we have something that reaches the maximum of our sine here and something that reaches the minimum of our sine dip here. This stuff in purple, this actually is the cosecant graph, but we graph our sine to come up with a guideline. But if I were asking you just to graph cosecant, you would only have the U shapes. You wouldn't have our sine. However, every time we do graph it, we want to graph the sine function first, like that's really our starting value or starting place, and then we put in our graphs of cosecant or our graphs of secant. So same thing for our secant function. So we're going to start by graphing cosine, which has a normal period of 2 pi, and our critical values of pi over 2, 3 pi over 2. And our cosine starts at 1, 0, -1, 0, and back up to 1. So that's what cosine looks like. Kind of missed a little. Whoops. And again, we have these asymptotes where our cosine or our sine is 0. In this case, we're looking for these zeros. It happens at pi over 2 and 3 pi over 2. So these are going to be the guidelines then for our U function that we're looking at for cosecant. So this one would also have one over here, but we'll just draw in just a little guide for that. To go up to infinity for these sections and then down to -infinity for that section. And that's our secant. So again, it's not really that different because we have all the same transformations that happen for sine and cosine. All we really do afterwards is we find where those zeros happen. We draw on our asymptotes, these dotted lines, and yes, I do need to see those. And then we draw our secant function to go from those maximums. So we're going to graph the primary. trig function, which is either sine or cosine. And we're going to draw in our asymptotes. These are our x-intercepts, our zeros for our cosine or our sine functions. Sometimes though, when we talk about our x-intercepts, this will change because when we have our vertical shifts, we have that like new baseline, and we just have to look for the zeros of where it crosses that new baseline. And we'll sketch these symmetric curves that we have using the minimum and maximum y values of our sine and cosine. So we have 3 to look at. Again, we're going to do like the same process that we did before. So we're going to come up with our lists, our amplitude, our period, our starting x, our ending x, and our vertical shift. Remember always to factor out a b value if we have some sort of parentheses here and we have a phase shift. We have to make sure that our b value is factored out because that will actually represent our phase shift a little bit better. For this one, we don't have to worry about that, but just in the future, make sure you do that. So our amplitude here is 2. And again, we're going to start by graphing the sine. So we'll look at this graph and come up with all of our information, and then we'll, for our cosecant, we'll just draw in our symmetric curves there. So our period is 2 pi over b. This is our b value, so 2 pi over pi over 4. So I'll reduce that down, multiply by the reciprocal, so we multiply by 4 over pi. Pi's will cancel, so we'll get a period of 8. We don't have any plus or minus d values here, so our starting value is going to be 0, and that means our ending value is just 0 plus 8, which is 8. And our vertical shift here is up 1 unit. So this one's nice and easy to come up with our averages. So our x values are 0 to 8. We have an average of 4, an average of 2, and an average of 6. We have a vertical shift of up 1 unit, so this is going to be our new baseline. Again, this is serving as our x-axis, so when we come up with our actual intercepts, we have to look at that baseline. That'll tell us where our asymptotes are. Sine, so that's what we're graphing right now, has zeros at our first, third, and fifth critical value. And then from here we can look at our amplitude. So we'd be going up 2 units from this new baseline and down 2 units from that new baseline. So 0, and at 2 we'd going up to 3, and then at 6 we're going down to -1. So there's our sine. However, we're not done yet. We need to graph our cosecant. So we have zeros at 0, 4, and 8, that first, third, and fifth critical value. So again, these are going to serve as our asymptotes because that's where our sine function is 0, and we know that cosecant is 1 over sine, so we can't actually divide by these values when we plug it back in. And then we draw in our symmetric curves. So again, it's not really too crazy. It's pretty much everything that we've been doing so far. We just have this like one added step. And the last thing we have to do is come up with our range. Now we've been coming up with our range of our sine and cosine before, so it's the exact opposite of those things. So instead of our range going from -1 to +3, it's everything except that. So we're going down to -infinity, up to this value of -1, and then we start at a maximum here of 3, and then go up to infinity. That's our range of our cosecant. Okay, 2 more. And like you might want to just pause the video and try example 2 and see if you can get there. Start off, again, we're going to end up graphing the primary. which is going to go along with cosine, and so that's where we're coming up with all of our important values. So our amplitude for this one, we don't have anything in front of the cosine, so that's just 1. Our period would be in front of like our x value. Again, we have to factor out a b value if we have one, but for here we don't have anything in front of that x, so our period is really just 2 pi over 1, which is just going to be 2 pi. Our starting x value, we have this plus pi over 4, which means we're going to move to the left pi over 4 units, so our starting value is negative pi over 4, and our ending x value is negative pi over 4 plus 2 pi, plus our period. So again, you can do that in your calculator, or you can just find a common denominator and come up with that value. So negative 1/4 plus this, to make that into a common denominator, would be 8/4. So we'd be ending at 7 pi over 4. And our vertical shift is going up 2 units. I forgot about our reflection. Don't forget about that. So we're starting over here at negative pi over 4. We're ending at 7 pi over 4. And then we can find those corresponding averages. So if I take negative pi over 4 plus 7 pi over 4 and find the average there, you should get... Just want to make sure that you should get 3 pi over 4. There we go. And if you do it again, negative pi over 4 plus 3 pi over 4 divided by 2, you should get 1/4, so that'll give you the pi over 4. And then same thing here, 3 pi over 4 plus 7 pi over 4 divided by 2 will give you 5 pi over 4. We're going up 2 units, so that's our new baseline. And we have an amplitude of 1, so we're going to go up 1 unit and down 1 unit from our new vertical shift here. For cosine, we have critical values at our 2nd and 4th, so pi over 4 and 5 pi over 4 that'll become. We have reflection, so normally we start at above our x-axis, but here we're going to start below it, go up to our 0, up to our maximum, and then back down to our minimum. So this is what our cosine curve looks like. But we're not done yet. We're actually graphing cosecant, or sorry, secant. So we have our zeros at our new zeros on this, like our x-intercepts on our new baseline, which happens at pi over 4. That's where cosine is 0 and 5 pi over 4. And then we'll draw in our symmetric curves that follow those baselines. And don't forget about our range. We're always starting from a negative infinity and going up to some number, and then starting at that number and going to infinity for cosecant and secant. This number that we're actually looking at goes up to positive 1 and then starts back up at positive 3. And this always, too, same thing for our range of our cosine and our sine values. This really is like our vertical shift plus and minus our amplitude. So our vertical shift is 2, so we subtract our amplitude, which is 1, to get our ending value in this first section of 1, and our vertical shift of 2 plus our amplitude gives us that 3. Okay, last one, a little bit more difficult. We're going to graph, again, our primary, which is going to be sine. This one, though, we do have this b value, so we're going to have to factor out a 1/2. So I'm just going to do that now. If I factor out a 1/2, that means I'm dividing by 1/2 for those things. So if I take, I'll do it over here, negative pi over 4, and then I divide by 1/2, I would multiply by the reciprocal, so I'm multiplying by 2 over 1, which will give me negative 2 pi over 4, which will reduce down to negative pi over 2. So in other words, dividing by 1/2 is really the same thing as multiplying by 2. So that'll be our B value is going to be 1/2, and then that's going to be our new phase shift. So we're going to graph this function for our sine, and then we will go back and draw in our symmetric curves with our asymptotes of where this actually ends up being 0. So I'll make our little summary here. So our amplitude is right in front, so that's 3/2. Our period is 2 pi over our b value. Our b value is 1/2. So again, dividing by 1/2 is the same thing as multiplying by 2, so we should get a period of 4 pi. Our starting x value, we have minus pi over 4, so that's going to be positive pi over 4, moving to the right pi over 4 units. And our ending x value is our starting x value plus our period. So again, you can do that in your calculator if you need to, but for this one, if I want to make this out of 4, it would be 16 pi over 4 plus 1, which is going to be 17 pi over 4 for my ending x value. And my vertical shift for this thing is moving up 1 unit. So I have a starting value of pi over 4. I have an ending value of 17 pi over 4. You can find the average of that. So 1 pi over 4 plus 17 pi over 4 is 18 pi over 4 divided by 2 is going to be 9 pi over 4. Same thing, 1 pi over 4 plus 9 pi over 4 is 10 pi over 4 divided by 2 is 5 pi over 4. And 9 pi over 4 plus 17 pi over 4 is 26 pi over 4 divided by 2 is 13 pi over 4. Our new x-axis is our vertical shift, which is up 1 unit. So I'm going to draw that in. And from there, we'll be doing an amplitude of 3/2, which is 1.5. So we'd be going up 1.5 units and then down 1.5 units. We're graphing sine in this case, which has zeros at our first, third, and fifth critical value. And from our baseline, our second critical point is going up 1.5 units from 1, that vertical shift, and then down 1.5 units from that vertical shift. And we get our sine function here. And last but not least, we just have to graph our symmetric curves here. So we have our asymptotes at our zeros, which is pi over 4, 9 pi over 4, and 17 pi over 4. And then we can look at our maximums and our minimums of our sine and cos, or our sine graph, and that will give us our cosecant. And then last but not least, we got to come up with our range. Again, we're going from -infinity to some value, and then from some value to infinity. So we just got to figure out what that is. For this one, I'm just going to use actually, like, instead of looking at our graph, and I'm going to go back and confirm that, I'm just going to look at our vertical shift and our amplitude. So if I take the vertical shift that I have up 1, so plus 1, and I subtract my amplitude, 1 minus 1.5 is going to be 0.5 or 1/2. Negative 1/2, which actually does happen. So like on our, this is our x value of 0, so we're at a maximum here of negative 1/2 for this section here. And then for my other section, I'm going to take that 1 and add my 1.5, which is 2.5, which is 5 over 2, or you could leave it as 2.5, that's fine too. So that actually does happen here on our x-axis. So there we go. So again, it's like not really that crazy different. Like we still are graphing our sine and cosine, and we're still doing all of the normal things that we did with our vertical shift and our phase shift and our period changes and our amplitude. And then all we have to do is find our asymptotes and then draw in our symmetric curves.